Greetings. So I'm in the middle of doing a bunch of videos for microcontrollers, but I ordered these things a little while ago, and they came just the other day. So I thought I'd do a little sidestep here and have a look at this, some of this M5 stack stuff. There is a Digi-Clock unit. A little of the text here. And which is basically what this is. And I've got an RFID 2 unit. So this is an RFID card, so we can use that to see if we can read that with it. So let's have a look at the listings for it first. Okay, so this is the RFID 2 unit. That's on the M5Stack webpage. And runs at 13.56 megahertz frequency, and it has this WS1805S chip, which I've had a look at, and it is a Chinese chip with only a Chinese data sheet, which I had to translate into English, but the data sheet did not have any information on how that chip is programmed. So that could be a drawback of that device, I guess. I'm not 100% sure. In fact, I don't know all that much about RFID. I must look into it a little bit more. I just thought that it would be something interesting to perhaps do a video about or something later on. Enables non-contact and two-way information interaction, and good for using authentication, authorization, and so on and so on. It's $5, and they do have a page on it with the information about it and so on. Next, we have this unit Digi-Clock. It basically looks like that, and it has a I2C, I2C interface over there, and it says it's got 8 brightness levels, but I have not been able to change the brightness levels. Always seems to be the same brightness. There's always something going on with these M5Stack things. You can use it for clock display, data display, and stopwatch. Basically, it has this TMS 16 something or other. Is it now 1637 or something like that? LCD chip there that is common, but it has a little microcontroller on there which actually gives it an interface. You can send strings to it and stuff like that, and it'll display it. The display itself, like here, it has 4 digits, and it has decimal points between each digit that you can turn on or off, and also a colon for like a clock display, and pretty simple circuit. It has a dip switch so you can change the I2C address. And some information there that I'm not sure if it makes 100% sense to me, but there is a sample program, and they show you how to use it. If you send these characters to it in a string, uppercase A, lowercase b, uppercase C, and so on, it will display these characters on the 7-segment display. In case, like I did a little program for it, this will go through, and if there's an error, I put E and then RR so you can read that there was an error. That's really all that there is to say about it. Okay, let's have a look at the this little RFID unit first. I've actually got it hooked up to. Let me push this out of the way here. I have it hooked up to one of these little Chow microcontrollers, like so. And as you can see, it's got STA and SCL I2C pins there, so I hooked it up to pin 4 and pin 5, and I picked up the 5 volts and the ground from it, as you can see over here. I made up this little adapter board. You've probably seen this before, so I don't have to solder pins on these things, and I just have a little rubber band to hold it down on a bunch of pogo pins. So if I plug this in, we should be able to see what it does. Let me get the cable. Okay, so let's plug it in. Now I've got a little demo program here. Let's get rid of this for a sec, which actually I downloaded from the M5Stack GitHub site, and it was originally set up to, that's why it says M5Stack H, to display its information on one of M5's little displays. I don't have one of those things, and I couldn't be bothered to hook up a display, so I changed it to output all its stuff on a serial monitor here. And this is all there is. So now the chip in there is not actually an MFRC 522, but the code is exactly the same, and the same code works with this other chip, so they didn't even bother to change it. They still have MFRC 522 tests, so don't let that, and including the library, so don't let that confuse you. Again, the library, these are the two files. I put them in the same folder, and they are actually available on their GitHub site. In fact, I've got software and documentation for everything on there. I'll put a link in the description. So all you do is create this MFRC 522 object, tell it to go to I2C address is 28, and then you say MFRC 522 PCD init, and then it displays a message, not in proper English, but I didn't edit it. Please put the card. It really should say, you know, to touch the F2C units with a little card. I've actually tried it with a bunch of these new credit cards that have that little symbol on there that you can just do a tap. They actually respond to this MFRC, and it comes back with a bunch of information, some with 4 and some with 8, some with 6, some with 4 and some with 6 sets of hexadecimal numbers, as far as I can tell. And that is what this loop here does. It says if there's a card present, and then it reads the serial. I know nothing much about this RFID thing yet. I must do some reading up on it. Perhaps it is able to read some other information from it. I don't know, but this is just an initial test to see how it might work. So when we actually run it, It is running right now, so it says the test, please put the card. So if I put the card near it, you see it just reads the information. F5767F3A. This happened to be a little card. Every time you buy something from M5Stack, they send you something like, this time they send a roll of sticky tape. They should have really sent one of these, but I bought stuff from before and I haven't got this RFID card, which now comes in handy because I can read it with that. I'm not going to read any of my credit cards in case you guys are smarter than I am and you're hackers and you can read the data there and do something nasty with it. So that is the RFID thing. Next, let's have a look at this Digi-Clock thing, which is a bit more interesting. Okay, so first of all, what we have is, this is one of these ESP room things, and that actually is the one that has an antenna connector on there. I salvaged this out of an old laptop. This is the antenna that it's using. It's just an old HP laptop. It had two of those ones on each side of the screen, but it seems to work just fine, picking up the Wi-Fi signal. So I just put it over there and drape it over top of something. And this is an ESP32, so it actually has its, where's the chart over here? It actually has its SPI interface, I2C SCL, I2C SDH 21 and 22, which is actually what it is defaulting to, so I didn't have to change that in the code. And of course I'm picking up a ground and a 5 volts. It says V in 5 volts with its output as well. Now another thing that I've done is I've hooked up a little dip switch over here with, and only two of the two switches are used. We'll go to the code and you'll see if this one is turned on, it'll flash the colon. You see it flashing there. If that's off, it won't flash the colon. The other one, if it is turned on, will make it, when it restarts, will go to 24-hour mode. So now it says 1800 hours. It's hard to see that display. If I put this little bag over the top of it, you can see it a bit better. It says 1843 right now. And if I put it back there, and if I turn the other one off as well, takes a second and a half for it to get onto the Wi-Fi and query the NTP server at the time. So now the colon is not actually flashing. So whatever, it's just a thing that I wanted to experiment with. The code, of course, is experimental. So let's have a look at the code. Now, what this thing actually does is, before we look at it, it connects to the Wi-Fi. It then accesses an NTP server, a default one on the internet, to get the time from. And then it actually programs these ESP32s have a real-time clock in them. But of course, it is only as accurate as what the little crystal that runs the microcontroller is at. And furthermore, of course, when it wakes up, it doesn't know what the time is, so you got to initially set it in order for it to. So that's where the NTP server comes in. They have like an atomic clock or whatever it is over there somewhere on the network, and then you tell it, give me the time, and then you will the real-time clock we adjusted so that I'm on mountain time, so I'm 7 hours behind the general mean time. So that's really all to say about the hardware. There's nothing special about it. but the code is interesting. So let's have a look at the code, how you program this thing. So there we go. Okay. So this one I coded in platform IO, because when you move your cursor over stuff, it's got way better IntelliSense and stuff than what the Arduino IO IDE has. But I have run it in the Arduino IDE as well, and it works perfectly there. It's exactly the same. So whatever you prefer. In any case, I have 3 libraries. I've got the M5Stack M5 unit Digi-Clock, which is actually published on the platform IO and also in the Arduino library stack that you can just grab. I found a library that somebody has written for the NTP client, and I found a library somebody else has provided for written for the ESP32 real-time clock, ESP32 time, and that is what these 3 guys here are. And that is why, and of course the module I'm using is actually, I've had it for probably a couple of years when I bought it, and I haven't really used it much other than I did a little test on it. So that's the first time I'm kind of using it or something. And that board is not actually published anywhere, but I found that it is pretty much follows the expressive ESP32 development module hardware and stuff, and it seems to work just fine. So I selected ESP32 development dev module, and that's what that's all about. So that is why we have these header files here. When you in platform IO, you always got to tell it that you're using the Arduino platform, because there's others that you can use as well. And that is what that's all about. You don't see that in when you go to the Arduino IDE, because they only support Arduino, so they don't have that. We're going to be talking I2C, so you always need the wire library, which is built into the system. You don't have to import that, it's always there. This is the M5 unit Digi-Clock library header file, the NTP client library header file, and the ESP32 time header file. And then we're going to connect to Wi-Fi, so we need Wi-Fi and Wi-Fi UDP, because UDP, that's a internet protocol that is used to talk to the NTP client. There are some links here to those GitHub pages. I can put those in the description as well, but I put them in the code to remind me if I look at it later. The Wi-Fi credentials are here. Now, most people kind of blot that out. I don't care, because this is actually, I've got a router that has a guest mode on it, and after I've done this video I'm going to change them, so good luck with that. If you pick those up, you'll never be able to use it on my site, and if you're Dutch, you know what these words mean, and I'm not going to translate them. Okay, so we get the Wi-Fi UDP, and we call it NTP UDP. We are starting the real-time clock, and we're telling it that we are going to be using a time which is 2500 to 25,200 seconds earlier than what the general mean time is, because it is actually, this is like 1 hour 3600 times 7, and it's negative, so you could put that in there. I've had that in there before, but I decided just to put the number in there, didn't have to do those calculations. So it's general GMT minus 7, and NTP client, the initialize, and we give it the NTP UDP object to work with. The pins for the SDA and SCL, as you saw on the list earlier, 21, 22. The address is 30, and that little dip switch, I called it flash pin, and our 24 pin is on GPIO 32 and 33. And then we have the M5 unit Digi-Clock, and I called it CLK. Initialize starts that object, and I've got a few little variables here. Do we want the colon to flash or not? Should the colon be shown? Which this is used internally if flash colon is on. Every second, turns it on and off if it's flashing. And or do we want to use 24-hour? Many Americans call it military time mode or not. And let's open that up. I created a few little functions here in order to make it not to duplicate code. So let's get a time string so to display it, and if we are using 24-hour mode, then we want to go here. Otherwise, if we're doing AM PM 12-hour mode, go here. And if the colon should be included, then it goes over here. And other than that, if the first digit is 0, we blank it out because we don't want to see 0, 1 hours. We want to see just space 1 hour. This is a little method here to read the mode switch. If the flash pin is low, then we want to flash the colon, and if the digital 24-hour pin is low, then we want to use the 24-hour mode. Nothing much to say about that. Setup here. Set up the pins for that little dip switch. Read the mode, and of course we said this is what that was. It sets the variables there, the global variables. Then we want to initialize the clock, and we tell it to use this I2 squared wire interface, SDA, ACL, and the address. If it doesn't work, then it has failed, so we can't actually continue, so we'll just let it hang over here. And in that case, we do a serial print line that the digital clock had an error, because that's the only way we can output stuff. The display is not working. So we have the buffer, character buffer here is a blank, so we set that to the clock to blank out the display. And we set the brightness, I set it to 6. You can go up to 9 with it. I didn't think that was working, because when you go 6, 7, 8, 9, it doesn't make much difference. So when you go below that, it does actually get a little bit dimmer, and 0 is actually off. So I stand corrected, it is working. Sorry, I seem to have a bit of a frog in my throat the last few days, and I keep clearing my throat, so if you're wondering what these funny noises are that I'm making, that's what it is. Okay, so where were we? Yeah, brightness. So we then begin the Wi-Fi. You see what I mean about the platform I/O? You hover over something and it gives you a whole bunch of information. Interestingly enough, you can do the same thing with your own code. You can right-click on it and you can say generate the oxygen comment, and then you can put some text over here. something like that. Now I've got this cheap keyboard which goes to sleep, and then the first couple of keys that you hit if you haven't used it for a while, the characters don't come out. Let's get a better keyboard one of these days. Okay, so when you do that, then when you go to a place where it says, you see, hover over the function or method there, it'll tell you read the mode switch and global values accordingly. So that's kind of useful if you're writing a library especially. And if there are parameters there, then obviously the parameters come in as well. Like, and over here it returns, it tells you what it returns. See, I'm surprised. I think if I delete that, and tell it to, I must have generated that when there was no, yeah, you see, I probably generated that when there was no, when that include colon wasn't there yet. So you have to delete and start it again, but I saved it so I can actually go like that. Just doing Control X and then Control V to overwrite it. So now, and I go to the place where it says get time string. I think it's at the bottom. Yeah, see, it'll tell you, or it'll remind you what it's all about. I like that. Is much better than what you have available in the Arduino IDE, and this is also much quicker. It compiles quicker. Everything is just, the editor is better. There is no comparison, but sometimes there is not a library available here yet, but it is in the Arduino, and then I will still dip into the Arduino occasionally, and just for simple things, but for anything more significant I use platform IO. Okay, enough of that. Back to the code. Where were we? Okay, Wi-Fi begin. So we're giving it the SSID and the password. Try to connect the Wi-Fi. If it retries every half a second, and you might notice that when I first turn it on, it counts to 3. So it takes 1.5 seconds to actually connect and to do its business. That's what it's doing here as printf in the buffer there that we actually defined over here. Put the decimal version of the count, then we send that to the clock display, and it'll go, you know, like 1, 2, 3, 4, 5, up to 30 if it's at 15 seconds. If it can't connect after 15 seconds, I don't know. Maybe that should be a longer time for some slow computers or something. I'm not sure. But I'll get it that 15 seconds should be enough. Excuse me. Then we will display ERR on that little clock display. And remember, we looked at it earlier, there's uppercase E and lowercase r's are available, so you can actually do that even on a 7-segment display. And so that's what we're doing here. And if it can't connect after 15 seconds, we will just make it stop here. Originally it had all serial print values in there, and it was printing a dot, and it would try forever, but I commented that out. So then once we got the Wi-Fi going, we can actually tell the NTP object to start, and as you can see, it was given the NTP UDP thing, and you can actually put values in there if you want to. The 3600, but I tried to set the time offset. Recently this was called time client. Should now be called NTP. There's a function that says set time offset, and I put -7 in there, and that didn't seem to work. But in hindsight, maybe that should have been in seconds or something. Maybe, I'm not sure. In any case, that didn't work, but it doesn't matter because we actually set the real-time clock, which is actually what we're reading and displaying from, and it has, which is what we're doing over here, you see. But anyway, just before we did that, the update over here, it says should be called in the main loop for application. By default, the update is only made every 60 seconds. I actually made it, I don't need to call it every time in my loop. I set that to an hour because I'm using the ESP32 real-time clock to keep the time. I don't have to call it each time to see what the time is. And once an hour, you'll see it'll update just in case it has drifted a second or two or whatever. So in any case, but this is the update, so it now has the current time and information in that NTP object. Then we can actually program the real-time clock in the ESP32 and set the time. So we'll get seconds, we'll get minutes, we'll get hours, and we'll get day. And the NTP object for some reason doesn't have a function to return the month and year, but that doesn't matter, we're not using that anyway, we're only displaying the time. So I just set that to January in 2023. And this gets time thing that is actually using the get time string. It uses the standard C++ strf time, and you can put parameters in there. I guess I should actually move this to where that is used now. I moved it, you see. I should move it here because this is where that get time call is. And as you can see, you can tell it to return the hours and the minutes. It's like a format string, and if you don't want the colon, you just leave it out. And if you want a 12-hour version, then you use I instead of H in order to return the hour. Okay, so we made an improvement there, something that this is just test code, and I've been fiddling with it. So okay, so we set the time, then we can get the time string, and you just saw it there. It depends on whether we want to display a colon or not, and whether we've got 12 or 24-hour switches on and all that kind of stuff. Then goes into a string. We then put it in a character array. I really hate that about C++. It is so rudimentary. I normally program in C#, and you'll find that later languages like C# and even Java and so on, they have proper strings. And in this C++, there is a string, like over here, but half the functions, they still use character buffers terminated with a 0, and for decades these programs used to crash because they have these buffer overruns, and that's why, because they program in C++, something that doesn't tend to happen in higher level languages. Anyway, just a little rant why I hate C++, but we're stuck with it. So anyway, I don't like Python either, so there is no real other option. So in any case, we then set string is when it actually sends it to the M5 unit Digi-Clock to be displayed, and we are actually still in the setup. So I'm setting the setup update interval to actually an hour. I don't see any reason for it to query and do any network accesses and all that kind of stuff more often than that. And therefore we're setting a little local variable or global variable here that the start hour it starts with 0. And then I read the current hour, so I'll get to the real-time clocks. It says give me the hour, and I want it in 24-hour mode. So for this course here, I want to be able to distinguish between 1 and 13 for 1 p.m. and 1 a.m. So if the start hour is not equal to the hour now, then we actually do this update, and we actually will read the time and from the NTP server, and we'll set up the real-time clock just in case it has drifted a second or something like that. But we create a string here. We get the time string, and we have this global variable show colon that it passes on there. Then it toggles show colon. If it's true, it will false. If it's false, it will become true, so that it'll flash every second. And it then updates the display, and it delays a second. So then it goes through and it updates it for the next second. And I originally based this on a M5Stack rather example code, and they were just doing stuff with that little display here. They were displaying 8.8 points colon 8.8 point to show that you could turn all the digits, all the segments on. They were changing the brightness from 9 to 0, but they were doing it so quickly. I changed it to 1/3 of a second, but they had like 150 milliseconds. You couldn't really tell, it was so quick that anything was changing. Anyway, this gives a hint as what you can do with the thing other than what I'm doing with it. So that's it. That's the code. So this is how you can get the time, set the real-time clock, and then display it. Now obviously this is basically some initial test code, but it would be possible to design a little case for it with a 3D printer and put a little microcontroller in there, probably one of those style ones, a little tiny one instead of this big broom thing. And you could put some little buttons on there, or a little, maybe a tiny keypad or something, whatever you've got. And you could actually make a clock, and you could make it so you can set alarms with it if you got a little keypad and some little switches and stuff. And you could also use it as a timer, because then you could set it to timer mode, and then you'd be able to input the how many minutes and hours and seconds and all that kind of stuff you want to wait. Put a little buzzer in there. So all that is possible with this kind of thing, with microcontrollers and this kind of display. But basically they call it a Digi-Clock, and it's currently 7:12 p.m. They call it the Digi-Clock, but it's not really a clock. It's a clock display, and there's a little tiny microcontroller on there that actually takes strings, so it makes it a little bit easier to set the display. There is of course that chip on there, that TMS16325 or whatever it is. Normally you have to talk to it, and it is harder to talk to than, this makes it more convenient to send strings to it, and it's I2C, so it only needs 2 pins on your microcontroller. Probably run this off a little 80Tiny as well, but I'm not sure if it has a real-time clock in it. In any case, this is what it is. So I thought that'd be interesting, and if maybe I'll do a more extensive project with it at some stage. But this is what I've got right now, from a couple of new M5Stack devices, RFID 2, and this little clock display thing. So I'll see you guys later. Don't forget to subscribe and like and bell buttons and all sorts of stuff, and I will see you later.